I'm going to do two common heat capacity questions. How much energy is required to heat 168 grams of copper from minus 12.2 degrees Celsius to 25.6 degrees Celsius? The specific heat capacity of copper is 0.385 joules per gram Kelvin. Good strategy is always to identify the things that they're asking you to find. So in this particular case, it is energy as heat, so Q. Then identify all the things that they have given you. So we have mass equals 168 grams of copper. We are also given T initial and T final, or T1 and T2 if you like. So T1, T initial, is minus 12.2 degrees Celsius. T final, or T2, is given as positive 25.6 degrees Celsius. And we are also given the specific heat capacity of copper as 0.385 joules per gram Kelvin. Now, if you cannot recall the formula for Q, you might be able to reason it out. Whenever you're heating something up, you need to know the temperature difference. So we need to know delta T. You also need to know how much of stuff you have. So you need to know mass. And you also need to know how well it takes up heat, which is the specific heat capacity. So CS. And lo and behold, those are the things that we are actually given. Notice that the specific heat capacity is given as joules per gram Kelvin. So it might be a good idea to convert our temperatures into Kelvin as well. So let's do that quickly. So this becomes 260.8 Kelvin. So all I have done is added 273 to minus 12.2. Then we have 2.56 plus 273 is 298.6 Kelvin. Okay, so Q equals, and delta T is simply T2 minus T1 times the mass times the specific heat capacity. So we have T2 as 298.6 Kelvin minus 260.8 Kelvin times the mass, 168 grams, times the specific heat capacity, which is given as 0.385 joules per gram Kelvin. And some units will cancel, so this gram and this gram will cancel. And also this Kelvin and this Kelvin here will cancel. So now we can have 298.6 minus 260.8 will give us 37.8, so that is the actual temperature difference, times 168 times 0.385 joules, and I may have jumped the gun on cancelling the units, but that's okay. So 37.8 times 168 equals times 0.385, and we get 2,445 joules. And that is good. We are only left with joules. We were after energy. Energy should be in joules. And if you wish, you can also convert it into kilojoules by dividing by 1,000. So you'll get 2.4 kilojoules after rounding. Let's do another one. So what is the final temperature of a 344 gram sample of iron if it absorbs 2.25 kilojoules of energy as heat? The initial temperature is 18.2 degrees Celsius, and the specific heat capacity of iron is 0.449 joules per gram Kelvin. So once again, What are they asking us for? Final temperature. What have they given us? So let's go. So final temperature, or T2. That is what we need to find out. We are given mass as 344 grams. We are this time given the heat absorbed. So Q is 2.25 kilojoules. We are given the initial temperature as well. So T1 is 18.2 degrees Celsius. And we are given the specific heat capacity, 0.449 joules per gram Kelvin. So once again, we're going to use the same formula. We just need to rearrange it a little bit. But before we do that, once again, we need to make sure that our units match up. So temperature in the specific heat capacity, we have joules per gram Kelvin, and our temperature here is given as Celsius, so we need to convert that to Kelvin. Pardon me, Kelvin. So it's 273 plus 18.2, which gives us 291.2 Kelvin. Our heat, our energy is given as kilojoules, so we need it in joules. We can do that by multiplying our number by 1,000, which will give us 2,250 joules. Okay, now we are ready to use our formula. So Q is delta T times mass times specific heat capacity, which is same as T2 minus T1 times mass times specific heat capacity. Now in this particular case we need to find T2, so we need to get T2 alone on one side. And we can do that firstly by dividing everything by mass and the specific heat capacity. So on the left we'll have Q over mass times specific heat capacity, and we will be left with T2 minus T1 on the right. And then we need to get rid of this minus T1 by adding T1 to both sides. So we'll have Q over mass and specific heat capacity plus T1 equals T2. And now we are ready to plug in the values. So Q we have as 2,250 joules. Mass is given as 344 grams times specific heat capacity 0.449 joules per gram Kelvin plus T1, which we have as 291.2 Kelvin equals T2. And over here some units should cancel, so this joules and this joules will go, this gram and this gram will cancel, and this Kelvin will come up on top. So let's just calculate what we have. We have 2,250 divided by 344, that was the mass, divided by specific heat capacity, which was 0.449, and that gives us, oh, let's just do that in white. Let me get rid of this. So that gives us 14.6, I'm going to round, Kelvin, plus T1, which was 291.2 Kelvin, equals T2. And finally, we just add the two numbers together, the two temperatures. So 291.2 plus 14.6 gives us 305.8 as our T2. And that is all for now.